Okay, guys, so I'm just going to kind of go through these quizzes on these videos so that you have an explanation. Now, just to note that if you did do these, if you did these quizzes online, they could have potentially had different numbers, but they would have been the exact same question. So if you go back to your quiz online and look at what I've done here, then that might be why it's a little bit different answer. So I can put these up on Canvas and you can look through them like as a blank copy, and I can work through them and you can try to work through them, and see if you get the same answer as me. But I just want to go through so that you have sort of an explanation. All right, so on this first one, it says the diameter of a circle is doubled. So the area, oh, it's not letting me write. The area of a circle is pi r squared. And so what I do in these situations is I just take the most basic number for the radius and I just put it like a 1. So which is just basically pi, right? Pi times 1 squared is just pi. All right, so then it says that the diameter is doubled. So that means that the radius would also be doubled. Okay, so now if you plug that into your calculator, you get like 12.566 something. So what I would do is I would take that 12.566 number in your calculator divided by pi. And if you take that exact number and divide it by pi, you should get 4. So the area is changed by a factor of 4. Okay. All right. Number 2, it says the homeowner is told that she must increase the height of her fence 46% if she wants to keep the deer from jumping to eat the foliage and blossoms. If the current fence is 2.8 meters high, how high must the new fence be? Okay, so her current fence is 2.8 meters. If you multiply that by 0.46, so 2.8 times 0.46 is 1.28. But we got to add that to the original height of 2.80. So you get about 4.09 meters. And I went with 4.09 just because we've got 3 significant figures in these numbers up here. So try to stay with the correct significant figures in your answer. Okay. All right, number 3, it says, then cleaning out the artery of a patient, the doctor increases the radius of the opening by a factor of 1.6. By what factor does the cross-sectional area of the artery change? So if you think about an artery, it's like a tube, and if you do like a cross-section of that, it's like a circle. So the area is still just pi r squared. Okay, and I think that these are probably the things that were confusing. So when I did the grade on this quiz, I did it out of like 6 or 7 instead of out of 10. So I mean, it definitely had a curve on it. All right, so again, what I did was I just chose the most basic number of 1, which is again just pi. And then I just took and I changed that radius to 1.6, and which gives you 8.04. If you take 8.04 divided by pi, then you get 2.56. So whatever it changes to, by whatever factor it changes to, you can just put that as your radius instead. Okay, the next one. This one says, if the following calculations, be sure to express the answer in standard notation. So it wants you to have it into correct standard notation, and it also wants you to have the correct significant figures. So we've got 3.78 to the 7th minus 4.571 to the 5th, which gives you this really long number. So it's like 373,429,00 on my calculator anyway. So if you're going to do that in correct standard notation, it's just 3.73 times 10 to the 7th grams. Okay, this is a 7 up here. Okay, you want to have 3 significant figures because of that number right there. All right, this next one you're going to just divide. So 6.307 times 10 to the 4th divided by 4.6736 to the 2nd. And I got 134.9, but again, it wants it in correct standard notation. So that's 1.349 times 10 to the 2nd. Okay, you move this over 2 places. And see how this is meters squared up top divided by meters on the bottom? So it becomes just meters on the top. Okay. All right, this next one, the label on a small soda bottle lists the volume of the drink as 636 milliliters. How many fluid ounces are in the bottle? 1 gallon is 3.785 liters and 128 fluid ounces is 1 gallon. Okay, so we have 636 milliliters. And what I would do is I would go from 1,000 milliliters to 1 liter. And then go 3.785 liters to 1 gallon. And then 1 gallon is 128 fluid ounces. And then go through and you can cross out, you know. So this is just your classic dimensional analysis. You just kind of have to see what you have and what you need. So if you take 636 divided by 1,000 divided by 3.785 times 128, you get 21.5 fluid ounces. And then this says that a competitor's drink is labeled 24 fluid ounces. So you've got 128 fluid ounces to 1 gallon. So I'm going backwards now. From the top one, essentially. So if you go through and do the math of that, so you've got 24 divided by 128 times 3.785 times 1,000, you get, this one is a little bit tricky because it's 709.6875. And how many significant figures do you need? Well, based on this number, you need 3. So you can't just do 709 because of this 6 right here. So you really should have 710 with a decimal there. That's how that would work. Okay, a nerve impulse travels along a myelinated, I think I totally just messed up that word. Oh well, not a biologist. It goes at 78.1 meters per second. And this is one that I think maybe it didn't give you the conversions or something for miles to meters. And so this was one of them that I thought, okay, we'll just, count it out of 6 or 7 instead of 10. And then we got 3,600 seconds to 1 hour. So on the test, I will give you all of the conversion factors that you need. I'm getting better at putting things on Canvas and figuring all of that out. So It's a process, guys. So you end up with about 175 miles per hour. Let me do that. Okay. Number 9, an equation for potential energy is mass times gravity times y, or height. It tells you that mass is kilograms, that y is meters, and that gravity is meters per second squared. Okay, so you've got kilograms times meters per second squared times meter. So what happens is you end up with kilograms times meter squared per second squared. This meter right here multiplies to that meter, so it becomes meters squared. Okay, so you end up with D as your answer there. And then number 10 was a little bit hard to read. I just kind of guesstimated here and there. I just went over and kind of did that and said it was about 5 and did this, and that was about, I don't know, 8. So, you know, if you were in the vicinity, then you should have gotten it correct. If you were online, it was a little bit more specific, but it was a little bit easier to read as well. So remember, whenever you do slope, you do rise over run. So you have 15 minus 10 over like 8 minus 5, which gives you about 1.7. And you really need to put your units, you know, because we were doing a kilometers versus hours, or position versus time graph here. So the slope is 1.7 kilometers per hour. Okay, so that is an explanation of our first quiz. And like I said, I'll put a blank one on so you can just kind of see a blank one and kind of work through it yourself. I would continue to try to work through some of the problems, you know, that you have in the back of your chapter. And the answers to, I think the odd ones are in the back of the book. But if you have any specific questions, you know, message me with the picture of it and we can try to work through it together, okay? All right, hopefully this helps.